Hello everyone. Today the topic I am going to explain is time series in data mining. Let's see the topic. Let's start with the basics. What exactly is time series data? It is just a data collected over the time. The data points are collected or recorded at a specific time intervals. It is common in domains like retail, finance, weather, health, and more. The time series forecasting is a key component of the predictive analytic in data mining. Now let's see. What is time series forecasting? Time series forecasting is all about looking at the past to the predict the future. Imagine if you are running a cave, wouldn't it be helpful to know when your busiest days are? That's what forecasting helps with. We look at the trends seasonally, repeat like weekends or holidays, and randomness. With the right model, we can make a pretty solid predictions whether it's for the next day or next week or even a year. This requires method that account for the temporal nature of the data. Example, stock prices, pot, product sales, and weather conditions. Now, what are the challenges in the time series forecasting? Of course, it's not all smooth sailing. Time series forecasting has its fair share of challenges. Real world data is messy. It might have missing values, strange spikes, or changing patterns over time. A big one is non stationary, which basically means the data behavior changes and that messes with our models. Okay, choosing the right model and the right parameters takes trial and error. But once you handle these issues carefully, you can build really powerful forecasting tools. And the dealing with outliers and noises are the one of the challenges in time series forecasting. Now we can see the one of the algorithm which we'll use in the time series in data mining is ARMIA. ARIMA stands for Auto-Regressive Integrated Moving Average. The star of the presentation is ARIMA. It may sound fancy, but don't worry. It's just a combination of few simple ideas. It works really well for the data that isn't seasonal but shows trends over time. What makes ARIMA special is that it looks at how your past values and past predictions error can be used to predict the future. It's been around for the decades and it still works for like a charm for many practical tasks. And it is a popular method in time series for recasting used for the modeling univariate time series data, and it is best suited for data that shows trends but not seasonality. Now let's see the components of ARIMA. Let's break ARIMA into three parts, and it will be not to be too complicated. The first one is AR, auto-regressive. We predict the future using past values. Example, today's sales influenced by sales in the previous day. And the second part is I, integrated. We will clean the data by removing the trends through differentiating in this step, and it will ensure that the data is stationary. And the third part is MA, moving average. We fix the forecast using the past errors, and like it uses dependency between an observation and the residual errors from the past forecast. Now we will understand the stationary of uh, time series. Here is a big one, stationarity. It just means the data doesn't change too much over time. Its average and variance stay roughly through the same. A time series in the stationary if its properties do not depend on the time and it have components like means, variant, and autocorrelation remain constant. ARIMA needs the data to be stationary to work properly, but real world data rarely is, but the real world data will be rare. That's why we use something called differencing. that will subtract the today's value from yesterday's to get rid of the trends. We also use the ADF test to check if our data is stationary or not. If it passes, we are good to go. And it also achieved using transformations and differentiation. And we have some parameters for the ARIMA. When we use ARIMA, we need to set three numbers P, D, Q. Now let's see what are these. First one is P. It stands for how many past values to use. That means if P equal to order of AR, which means a number of lag observations. And the next one is D. D it stands for the how many times we difference the data, and we can call it the degree of differentiation. And the last one is Q, order of MA, which means it will say how many past errors to consider in the dataset. Example, ARIMA, we have the values of 1, 1, 1, which one is user one lag and the one differentiation and one MA term. And we have a few steps to build the ARIMA model. The first one is visualize and understand the data. And it means nothing. It means look the data and plot it, explore the trends or seasonality. And the second one is check for stationarity, which means it uses visual checks and tests like ADF. And third one is apply differentiating to stabilize the series. And it means it uses the differentiating when it is needed. Fourth one is use ACF and PACF to identify P and Q. And the fifth one is ARMA model, build the ARMA model. It means the plug in the values using the Python or R language. And the sixth one is forecast. It will predict the future values. And the last one is validate or evaluate. It means it will validate the model using performance metrics like RMSE or MAE to see how accurate your forecast is. Now we can go through an example to understand the ARMA model. Here, here we can see the first cell. Here we can see the first cell of the code, which will use it to load the data set. By the data set is electricity.csv. We have uploaded the CSV file in file. And it will calculate the RMSE for forecast accuracy, and NumPy is used for numerical operations like square root. And the second cell we can see that it will import the data, and it will give the graph of a daily electricity consumption. And the next cell we can see that by using these by by using the ADF statistics and p-value, we have got the ADF statistics value, this one, and the p-value we have got. The ADF value is stands for augmented decay failure, to check if the data is stationary or not. And the next cell we can see that it will in this cell it will be differentiating the data set. And now we can see that there will be two differences. Which one? First one is autocorrelation and the second one is partial correlation. And the another cell we can see that it will fitting the ARIMA model. It will create a ARMA model with P by the values of P, D, Q. It will fix the model to the original data and prints the summary containing the coefficients and diagnostic information. By this cell, we can get the maximum ARMA model results for the electricity consumption, which we have been in a overall period of time. And by this cell, we can get the the past 30 days of a forecast of electricity in the past month. And the last cell of the data, which will split the data, all data except at last 10 points, the last 10 points used for the validation. And it will rebuild the ARMA on training data, and it will forecast 10 steps ahead to compare against test set. And it will calculate the root mean square error. We will got the RMSE value, and we can get the actual values and the predicted values. Now we will see the real world applications of ARMA. In, in first one is in retail. It helps predict demand and manage stocks. And second one in finance, it will forecast the stock prices or the interest rates. And it will be used in healthcare also. It can predict the hospital visits. And the last one we can say energy. It estimates the future usage and consumption of energy. It simply and reliably make it to go-to model for short-term forecasting, especially when data isn't too seasonal. Now we have a quick comparison of ARMA models versus other models. ARMA is great, but not perfect. There are other models out there. Which one is a SARIMA? Is like a ARMA but handles seasonally. And the next one we have the Profit. Profit by Meta is a super beginner friendly and works well with the business data. It will good for the trend and the seasonal effects built by Meta. And last one we have as LSTM. It is a deep learning model that captures complex patterns, especially in the large data sets. By conclusion, to wrap up, ARMA is a solid, trusted model for forecasting time series. It's simply to understand, easy to implement, and highly effective for many real-world tasks. And the main topic is the time series analysis, which is a critical component of the data mining that helps uncover pattern, trends, and future behaviors in sequential data. And ARMA is a technique that will make informed data-driven decisions by transforming past data into accurate forecast. ARMA helps you plan for better and make smart decisions. Thank you.